In this two-part lab, we'll learn how to perform network traffic analysis, and it's a core competency of any cybersecurity analyst out there. So network traffic analysis really refers to the process of inspecting and monitoring network traffic in order to gain insights into network activity, identify anomalies, and detect potential security threats or suspicious behavior. So let's get started, and before we do, make sure you have your network traffic analysis PCAP open along with the objectives file located alongside it, which we'll use for this lab. The first series of objectives are really about trying to identify which endpoints are active in this PCAP. So let's get started with the first one. Looking at the first objective, it indicates that we need to identify what the operating system is of the given IP address and its device type. Well, remember that user agent HTTP header that we saw before? Well, we can go and see if we can find that to identify what it is. So the IP address in question is 10.11.11.94. Let's filter for it. Filtering for http.request will likely include the user agent string. And now we specify IP address equals 10.11.11.94. And if we look, we can actually see a GET request. And that's exactly what we need, right? That's where the user agent string lives. So we can go and just follow the stream, and then we should be able to find the header right on the first portion of the request. Perfect. There it is. There's the user agent string. So what we have here is actually indicative of Chrome OS. And you could look that up if you like, but when you see CROS, then we know that this is a Chrome operating system, which is going to be running on a Chromebook. That user agent string is pretty powerful. Okay, objective number 2. Same thing, but it's actually a different IP address. So let's go and rework the filter and change the end portion to IP.address is equal to 10.11.11.121. Cool, okay, so another GET request. Let's open that up and see if we can identify the device and operating system as a result. And yep, there it is. There's the user agent string. So if we look at this, we can actually see that's running on Android 9 and that this is a Samsung SM TAC N50U, pretty sure. And yes, user agent strings can also indicate mobile devices. All right, making good progress. Let's look at number 3. And in this case, we need to go and identify the MAC address to get the vendor manufacturer information, really, with the IP address of 10.11.11.145. Okay, perfect. So let's go and find one of these packets over here. And what we're looking for is information from the source header. So if we expand the Ethernet header and go to source, we can find the MAC address there like we did before. And we can see that it's Motorola. And the OUI portion, right, is that first set of characters. So we have BCFFEB, and that's the OUI for the Motorola manufacturer. All right, on to number 4. So what is the operating system for 10.11.11.179? Well, let's go back to our old trusty filter, and maybe we can find ourselves another GET request over here with the user agent and just change that end portion to the correct IP address. All right, that's a lot of GET requests, so we could honestly grab pretty much any one of these. I'm going to go and grab packet 2120 in this case, and I'm just going to follow the stream and see if we can get some information from another user agent string. Okay, so we actually have a Macintosh, which really likely will indicate a Mac, and it's running on OS X 10.15.1. So a quick Google on that one will indicate to us that this is Mac OS Catalina. All right, we're really getting the reps in here now. We got one more objective, number 5. We need to do a little bit more versioning of the operating system, but this time for 10.11.11.195. So one more HTTP request filter, and let's see if we can find anything inside. Cool. Once again, plenty of GET requests. Let's go ahead and follow one of these streams over here. And good. So we can see the user agent string over here, Windows NT 10.0 64-bit. So this is actually Windows 10. And I know that, and you can look it up with a quick Google yourself, when we have the NT portion that actually stands for new technology. And is just a little naming convention that Microsoft went with to promote their very advanced Windows fancy operating system. So when we see Windows NT 10.0, we can safely assume that's Windows 10. Okay, so now on to objective number 6. And this one's a little bit harder. It wants us to find the user account name from the IP address of 10.11.11.200. And we haven't encountered something to that degree yet. So let's walk through it together. The first thing we might want to do to orient ourselves is just look at anything from the source IP of 10.11.11.200. And what we're looking for are any types of protocols or packets that we haven't seen before that we can investigate. So let's see. Cool. Okay, so we see there's SMB2 and LDAP. We haven't seen those before. Let's keep scrolling through this packet list and see if there's anything else we can find. And this one stands out, KRB5. This is the Kerberos protocol, and Kerberos is responsible for authentication. So let's see if we can find out if this protocol, based on authentication, has any type of header that we can identify a user account name inside of. Let's do some Googling for this. I was hoping maybe more for a direct result to some type of header, but maybe we should just Google for specifically what we need. So KRB5 user name Wireshark. Okay, so that first link looks pretty good actually. That's basically what we're looking for. So a lot of good info. Someone has a write-up over here of identifying Kerberos protocol activity. Let's search for username in this person's write-up. Nice. So it looks like the CNAME field would contain the username that's being authenticated. So let's scroll up and see what they have here. Okay, so in this case, the CNAME header right there inside the screenshot indicates the user account name. More specifically, the CNAME string, RCBJ. So what we need to do is see where can we find the CNAME string within inside of Wireshark. I think we need to Google a little bit more. Wireshark Kerberos CNAME. And let's see. So what's really cool is the wireshark.org website contains a full listing of all display filters we could use. So here we go. Here's a full listing for Kerberos. Let's search for CNAME. And it actually looks like we can filter specifically for Kerberos.CNAME string. And that'll provide a character string to us. Okay. I think that's what we need. So let's go back inside of Wireshark and see if we can filter specifically for that. Okay, so a little bit of filter tweaking. Let's go to the beginning and then type in Kerberos.CNAME string and let's see what comes up. Okay, so we have some results here, but I think I see a bit of a problem with our filter. We're still filtering for IP.source based on what we previously used. We should probably go ahead and filter for IP.address, and that will include a lot more packet listings for us to inspect. So let's change that now to IP.addr. Okay, that's better. That's a lot more of information for us to investigate. Okay, cool. So let's move into the packet details pane in the bottom left. Let's collapse the Ethernet header. We don't need that. Let's go inside of Kerberos, then authentication service request, then request body, then CNAME and CNAME string. There it is. Okay, so here we go. We have Gilbert Win7, but that's the host name. And we want the user account name, which will probably be inside of the CNAME string, but there's a lot of packets for us here to look inside of. So what we can do is something that's really handy, and we can go and add this as a column. And that will display this specific field from all the packets as an individual column in the packet listing pane. Awesome. So now we're utilizing Wireshark a little bit more, and look at that. We have this column of CNAME string data, and Brandon Gilbert is inside of some of those packets, but not every single one, which makes our life much easier instead of investigating every single one packet by packet. And that's a really cool feature of Wireshark. So as you can see, there's a ton of information carried over the wire, and it's pretty impressive what you can find, like user account names being logged in across the network. And this is what network traffic analysis is. So we'll carry on with part 2 in the next lab and do a little bit more hunting through this PCAP. We'll see you there.